So this is just another look at domain and range. We already took notes on this, but just another look so that we can get more practice at it. So looking at the first one, we have a set of ordered pairs. So a set is a discrete set of data. We can actually list each one of those out. So we have 4 specific data points. So we have a discrete set of data. We're going to write the domain and range as a set. So you might remember from the other day on the notes that we write a set with a squiggly bracket. So I'm going to start my domain and range, both of them with squiggly brackets. Remember that we also put the numbers in order from least to greatest, and we do not repeat values. So for domain, I'm looking at the x's. So I have -5, -1, 3, and another -1. So I'm going to write those out. I'm going to put them in order from least to greatest, and that -1 that repeated, I'm only going to write one time. So I'm going to put -5, that's the least number, comma, then -1, and I'm only going to write it one time, comma, and then 3, and then I'm going to close my bracket. So then the range is the set of y values, also from least to greatest. So I have 3, 0, -4, and 2. So all 4 of those are different. So I'm going to write all 4 of them. Again, least to greatest. So -4 is going to be the least, comma, then 0, comma, then next would be 2, comma, and last would be 3, and then close our bracket. And then the last thing here that it's asking is it a function? We did this last week, so hopefully remember a function is when x does not repeat. So these two x's, these -1s repeated, so this is not a function. So no, it is not a function. All right, so similarly, looking at number 2, again, we have a discrete set of data. We have very specific points that we're looking at, 4 specific points. So same thing, we're going to write our domain and range as a set with squiggly brackets. We put them in order from least to greatest, and we don't repeat. So our domain is our x's. So remember, this is your x-axis, right? So we're looking from left, so starting over here, going this way, left to right. So both of these 2 points right here on the left, they have the same x value. So that x there is -2, so I'm going to start with a squiggly bracket on domain and -2. I'm only going to write it one time, even though there are 2 points there. Then moving to the right, my next x is right here, this one right there. So that x value is 1 because it's 1 to the right. So 1, comma, and then the next one is right here, and that one has an x value of 2. So 2 is going to be my last domain, and then I'm going to close with a bracket, a squiggly bracket. Right? So range is the same thing, except it's the y's. And so we're looking at our y-axis, and again, from least to greatest, that means we start at the bottom and we go up. So both of these 2 points have the same y value. We're only going to write that one time, so that y is -1, 2, 3, -3. So squiggly bracket, -3, comma, going up. The next one is right here. So that y value is 1, 2. And then comma, last one is this one right here. So that y value is going to be 3, 1, 2, 3. So we're going to put 3, then we're going to close our bracket. That's 3. Close your bracket. And then again, a function is when x does not repeat. So on a graph, it has to pass the vertical line test. So if you're looking at this one, these 2 x's right here are on the same vertical line. Those x's right there are cheating at -2. So this is not a function. So we're going to put no, this is not a function. No. All right, so now we have continuous data. So continuous data is when points are connected with a line or a curve. So this shape is a curve, right? It's connected, definitely. We can't list out every single x or y value. There's an infinite number, all along this graph. There's, whole numbers and integers for sure, but there's half values, quarter values. So there's no way we could list these. So we're going to write these as an inequality. So again, what you're really looking for is there a starting and an ending point, one or the other or neither? So I'm looking at my x because I'm looking at domain first. So if I'm going from left, so this is the left, all the way to the right, and then I'm going to end over here. What I see is that this graph has arrows at the both ends of it, which means not only is it going to keep going down, but it's going to keep going out, both left this way and right this way. So there really is no beginning or end for this one. It's going to keep going left to negative infinity. Oh, let me get my page back here. So it's going to keep going left from negative infinity. Let me zoom in a little bit more. Negative infinity on this side, and then to positive infinity on the right-hand side. So that's every single number possible. So we call that all real numbers. So our domain for this one is going to be all real numbers. So I'm actually going to write out all real numbers. All right, and now we're going to talk about the range. So range, again, is our y, so we're looking at our y-axis. So we go from least to greatest, so I'm starting at the bottom, and I'm going up the graph. So at the bottom, you should see, again, that there are those arrows, right? That means it's going to keep going, so there's really no starting point, but as you go up the graph, there is an ending point right here. This y is never going to go above that. So again, it's down here, it's going to keep going to negative infinity, but up here, it's not ever going to go beyond this point, so that's where y is 1, 2, 3, 4. So the maximum y value is going to be 4, but then it's everything from 4 down, right? So we're going to write this as an inequality, and because there isn't an ending on these because of the arrows, it's just going to be a regular inequality. So that inequality is going to look like this. It's going to be y is less than or equal to 4. So it's everything from 4 down. And so if we go back to our graph for just a second, you should be able to see that, right? We start here at 4, and it goes everything below that. So everything from 4 down. It's equal to, because right there it's touching. If you can't see that, let me just erase all that so you can see that right there it was touching at 4, so it is equal to there. And then lastly, is it a function? So again, we're looking, are any of these x values ever repeating? There is no place on this graph that you could draw a vertical line that it would touch more than one time. So this is a function because you can put vertical lines everywhere here. None of those x values are going to repeat. So yes, this is a function. So I'm going to write that over here. This is a function. So yes. Alright, and then let's look at the last one. So this one we have an oval, or an ellipse is what we actually call it. So domain, again, we're looking at the x's. So if I'm looking at the x-axis, again, that's from least to greatest. So here's my x-axis. I'm looking from left over here all the way to the right. So what I notice is that this graph never goes beyond this point right here on the x, and then as I move to the right, it's everything to here, right? So all the x's for this graph are between -1, 2, so this is -2 on the left, to 1, 2, 3, 4 on the right. So our x value is everything between -2 and +4, right? It's everything between that. So this is how you're going to write that. This time we have a beginning and an end, so it's an inequality, but it's going to be a compound inequality. So we're going to put our x in the middle. So x is going to be everything greater than or equal to, because it's touching, again, -2, but less than or equal to, again, because it's touching 4. So if I go back, we're saying it's everything from -2 all the way to 4. Again, I went from least, so -2 is the least on the left, to the greatest on the right, the +4 on the right. So everything from -2 on the left over here, -2 on the left over here, to +4 on the right over here. Okay. All right. So then we do the same thing for the y's, except for our y-axis from least to greatest is going to be bottom to top. So we're looking from the bottom to the top. So If I'm looking from the bottom, I see that this oval is never going to go beyond this point. Notice it is touching right there, so that y is -1, -2, -3. And then it's everything from -3 up to right here, where y is 1. So our y's are everything between -3 and 1. And we start with our lowest, so -3, and then go up to your highest. So we're going to write that, again, as a compound inequality. So we put the y in the middle. Y is everything greater than or equal to -3, but less than or equal to 1. So everything from -3 to 1. Okay. And then last thing again is it a function? So remember, any closed shape is not going to be a function, and that's because when I draw a vertical line on a closed shape like an oval or a square or a rectangle or triangle, then some x value is going to repeat. So like this x value, those are repeating. Same thing for here and here, those are repeating. Here and here, those are repeating, or even over here or here. So everywhere you draw a vertical line, you have x's that are cheating. So this is not a function, so we're going to put no.